What's up? It's the last day on the Pythagorean Theorem, y'all. And we're moving on to more Pythagorean Theorem. Yeah, okay, we're not moving on for a while from Pythagorean Theorem. All right, today is day 3. We are looking at word problems with the Pythagorean Theorem. Not really word. Well, they're really, because they have words, yeah. So word problems dealing with a Pythagorean Theorem, a conceptual understanding that when you read a problem, that you can visualize what you need to draw in order to produce what the picture is asking you to produce in order to find the missing side. So we know the Pythagorean theorem works only with right triangles. That's what Pythagoras came up with the theorem. And so when we read these problems, we have to keep them in the mindset that we are talking about a right triangle. And so it's going to make more sense. So proud of the people that have been submitting their work and getting their answers right. Shout out to you. Shout out to the videos. And now let's get started in the lesson. So it says the hypotenuse of a right triangle is 33 centimeters long and one of its legs is 28 centimeters. What is A, the length of the other leg? So if this is a right triangle, whoa, boy, I gotta be checking my stuff, y'all. I just be starting and not checking my specs now. All right, let's deal with this blue. I don't think I hardly ever write with this blue. So we have a right triangle here, right? No pun intended. This side's a little dip, baby dip. So we have a right triangle, which is 33 centimeters long. The hypotenuse is 33 centimeters long. So I know the hypotenuse is across from the right angle. It's 33 centimeters long. And one of its legs is 28 centimeters long. But they want us to find A. Now, I identify A as the vertical side. It doesn't matter. No, it doesn't matter. And so the other leg is 28. How do I know those are legs? Because they make up the right angle. There we go. Those are my legs. So find the other length. Well, I know the Pythagorean theorem is a squared plus b squared is equal to c squared. And if I'm missing a, then I know that a squared is simply equal to c squared minus b squared. So what do I have to do? Find a, duh. So a squared is going to be equal to 33 squared minus 28 squared. And then a squared is going to be equal to, I do not know what 33 squared is. So let's go figure this out in Desi. Desi, where you at, Desi? I'm in emails. Lord have mercy. All right, so 33 squared. Whoa, doing the most. 33 squared is 1089. And what's the other number? So I can get that. 33 and 28. 28 squared. You can do shift 6. 1089 and 784. Let's go ahead and do this while this is here. 1089 minus 784 is going to give us 305. So 1089 minus 784 is going to give us 305. What do we have to do now? Take the square root. Take the square root. And a 305 is not a perfect square, so I know that's not going to give me that. So the square root of 305 is 17.4. Round to the nearest tenth. That 6 is going to round that 4 up, y'all. That 6 is going to round the 4 up. I'm going to write down this whole thing. 17.46. This 6 right here rounds that 4 up to a 5. We're rounded to the nearest tenth. 17.5. And what's our units? Centimeters. All right, the next one says a man drives 6 miles west and 8 miles north. Approximately how many miles is the man from his starting point? Now, I was talking to a student. They didn't know north, south, east, west, which I don't know where they were. I don't know. Given the context, y'all might not know it. All right, so you have a compass here, and so that represents north. This is east. This is south, and this is west. So, given the context, you might not ever. I don't know. I don't know. What's common is no longer common anymore, y'all. A man drives 6 miles west and 8 miles north. So when I see this problem, this is how I visualize it. I see that, first of all, you're starting someplace, right? So you're going 6 miles west. So I'm going in this direction here for 6 miles. And then after that, I'm going 8 miles north. 8 miles in that direction, right? So now, what is the man's, how many miles is the man from his starting point? So you started here, that's the starting point, your S at P. You're now at this point, you're trying to find out how far you are here. Will you look at here, y'all? What did we just make? What did we just make? A right triangle. Will you look at here, Lord? And so I am missing C, because that's the side across from the right angle. So I know that C squared is equal to A squared plus B squared. So C squared is going to be equal to A squared is 8 plus 6 squared is, 6 squared. And now we end up with 8 squared is 64 plus 36. 64 plus 36 is 100. Take the square root of that. We only want the positive answer. So it's not approximately. Why? Because it's actually equal to 10 miles. All right. So that's where he's at, 10 miles from the starting point. So today is definitely Edupuzzle, because I don't want y'all to move on to the next section without going back and answer these questions. So in Edupuzzle, this is going to be question number 1 once it shows up. So this is question 1, and you must draw a picture, and you're going to submit into Floop. So you're going to answer the question here in the open-ended, but then you're going to submit your work into Floop. You must draw a picture. This is number 2. You must draw a picture and submit your answer into Floop. And if you don't remember what north, south, east, and west, go back in the video, rewind it, and go watch it, because you must submit your answer here. Okay, now we are moving on to the last part of today's lesson. It is the understanding of what a Pythagorean triple is. So let's read the definition and make sure that we have a clear understanding. A Pythagorean triple is a set of positive integers that fit the rule A squared plus B squared equals C squared. Okay, so Pythagorean triple is a positive integer. What is an integer? An integer is a whole number and its opposite. So we think about 1, 2, 3, 4, 5, and the opposite of 1, 2, 3, 4, and 5. Let me get in your face. The opposite of 1, 2, 3, 4, and 5 would be -1, -2, -3, -4, -5. But we don't want negative numbers. Why? Because the sides of a triangle cannot be negative. So that's why we say the positive integers. So we're talking about 1, 2, 3, 4, 5, 6, 7. Integers are no decimals, no fractions. Okay? That might be a question I'll just throw in there. All right, so now I'm out of your face. So here, we're saying that the Pythagorean triple are positive integers that fit the rule A squared plus B squared equals C squared. Remember that the largest number is C, because that's the hypotenuse, and that's the longest side. If 3 positive numbers form a Pythagorean triple, then they could be used for the side lengths of a right triangle. The smallest Pythagorean triple is 3, 4, 5. Let's jump back for a moment so you all can see this. All right. So right here, this is the smallest Pythagorean triple, because these are the first numbers that are positive integers. So I've been using this diagram, and I just didn't show y'all all the time. That side is 3, this side is 4, and this side is 5. So this is the first set of integers where 3 squared plus 4 squared gives me 5 squared. What is 3 squared, everybody? 9. What is 4 squared, everybody? 16. And what is 5 squared equal, everyone? 25. So we are saying that 9 plus 16 is equal to 25. Since that is true, that is a Pythagorean triple. So that 3, 4, and 5 are our Pythagorean triples. Okay? So I'm going to say that again, because I have to make sure y'all understand that before I move on, which means a question is coming up. So 3, 4, and 5 are Pythagorean triples again because they are positive integers that make the rule true. And what is the rule that we're talking about? A squared plus b squared is equal to c squared. Why are they Pythagorean triples? Because they make a true statement. 3 squared plus 4 squared equals 5 squared is equal to 9 plus 16, which is equal to 25. 25 is equal to 25. Yes, this is true. So they are Pythagorean triples because they make the rule true. Now, y'all, I don't know no easier way to say this, but if you need to rewind the video, I know we need to practice, and we're going to get into that in a second. But they make the rule true. 3 squared plus 4 squared is equal to 5 squared. Okay? 3 squared plus 4 squared is equal to 5 squared. Because 9 plus 16 is equal to 25. Okay? All right. Okay, example number 2. Do the numbers 6, 12, and 9 form a Pythagorean triple? Go back, Mr. O'Neill. So what does this mean? That means that 3, 4, and 5, or you can look at it like this, because that doesn't matter. This technically be 4, and this technically, even though visually it doesn't make sense, this has to be 5. That's what it means. That means that 3, 4, and 5 are sides of a right triangle where 3 and 4 are the legs and 5 is the hypotenuse. That is what it means. That's what it means. Okay. All right, number 2. Do the numbers 6, 12, and 9 form a Pythagorean triple? Well, let's try them out. Let's try them in the rule. So when we're looking at the numbers, the 9 and the 6 have to be the smaller sides, right? So they have to be the smaller sides because 12 is the actual what? Hypotenuse, because it's the largest side. This has to be C. So this can be A or B. And so we're trying to see, well, does it satisfy the rule? 6 squared is 36. 9 squared is 81. 36 and 81 do not add to 12 squared, which is 144. So this is not a Pythagorean triple because this is not true. All right, let's try some. I think I've exhausted the understanding of what I'm trying to say. So we're going to do 2 together, and then you're going to have 3 to do. So is a triangle with side lengths 18, 25, and 33 a right triangle? All right, let's identify the largest side. This has to be C. Why? Because it's the longest side. So this is going to be A, and this is going to be B. So we are saying, this is the Pythagorean theorem, A squared plus B squared equals C squared. So we are asking ourselves, does 18 squared plus 25 squared equal 33 squared? So here we go, Desmos. 18 squared, 324. What's the other number? I always forget. 25, I know that number. Okay, 18 squared is 324. 324 plus 625. Is that going to give us 33 squared? 1089. Well, let's see, everybody. 324 plus 625. 324 plus 625 is 949. No, sir. 949 is not equal to 1089. This is not a Pythagorean triple. Why is it not a Pythagorean triple? Because 949 does not equal to 1089. So on the next one, we ask ourselves, well, is this a right triangle? So this is the longest side. This has to be C. I'm just going to let that be A, and I'm going to let this be B. So we are saying A squared plus B squared equals C squared. Does 12 squared plus 16 squared give me 20 squared? That is the question I'm asking. Now, this is honestly what I'm asking. So 12 squared is 144. 16 squared is 256. 20 squared is 400. All right, 144 plus 256 is 400. Yes, yes. So yes, we'll say 12, 16, and 20 are sides, or could be sides, of a right triangle. Why, y'all? Because they make the rule true. Well, everyone, it's been a pleasure being with you today. Hope you learned something. I know you did. Yeah. And so this is your work. I'm about to sign off without telling y'all what y'all got to do. What am I talking about? So that was 1 and 2 on the last one. This is going to, because it's a shorter video, y'all get to do a little bit more work. This is going to be, come on, turn the page. This is number 3, this is number 4, and this is number 5. You are doing 3, 4, and 5. You're going to show the work that you just saw in the last problem. All that work that I showed you, you must show yourself. You don't have to write down the problem, just write down the numbers and put them in and see if they're true. Okay? And you will submit them here and upload your answers into Floop. Submit them here and upload your answers into Floop. All right, now I am done. And this has always been another beast mode product. Whoa, what are you doing with your life? Beast mode production. This is Mr. O'Neal. I'm out. Like, for real, for real.